Welcome to solverfy.
Hello students, here in this question we have to find out the mass of hydrogen, where they are provided with the total pressure and the pressure of water. And from this equation of Dalton's law, the total pressure is equal to the partial pressure of the each components, that P equal to pH2 plus pH2O. Here we can find out the pressure of the hydrogen. On converting 150 torr into bar, that we will get the answer as 150 divided by 760 atm into 1.013, we will get the answer of bar in 0.2 bar. So as we know the total pressure and the pressure of water, we can find out the pressure of hydrogen, that will be equal to 0.96, that the total pressure minus the pressure of water 0.2, and we will get the pressure of hydrogen here as 0.76 bar. As in this question, the pressure, volume, mass, the temperature is all given. We have to find out the mass of hydrogen using the ideal gas equation PV is equal to nRT. And as we have to find out the mass of hydrogen, we can rewrite this equation as like this. The total pressure is 0.76. The volume is 76.8 into 10 raised to minus 3 liter into the volume is 2 liter. Sorry, the volume is 76.8 into 10 raised to minus 3. And here the mass of the hydrogen is 2, that is the molar mass, divided by the universal gas constant 0.083 into the temperature on converting into Kelvin is 3 Kelvin. Sorry, here it's also 3 Kelvin. So on doing this here, we will get the mass of the hydrogen that produced here as how much. We will get our answer as 4.224 into 10 raised to minus 3 gram. So this is the answer for our first question. And in our next question, we have to find out the mass of ammonia. As in this question, the pressure, volume, temperature is given. Here also we can use the ideal gas equation PV is equal to nRT. So here, how we will find the mass of the NH3? Here, the number of moles can be found out by rewriting the ideal gas equation as PV is equal to nRT. So from this, the number of moles of nitrogen can be found out by its given pressure is 0.85, the volume is 9.52 liter, divided by the universal gas constant 0.083 into the temperature 281 Kelvin, and here we will get the number of moles of nitrogen as 0.347 mole. And from this we can calculate the number of moles of H2, that will be equal to 0.85 into 13.5 liter divided by 0.083 into 281, and we will get the number of moles of hydrogen as 0.492 mole. As the 1 mole of hydrogen will produce 1/3 mole of how much? Nitrogen. Here 0.492 mole of hydrogen will react with 1/3 of 0.492 mole of nitrogen, and here it is equal to 0.164 mole. So the desired amount of nitrogen is less here, so we can say is that, sorry, the desired amount of hydrogen is less here, so we can say is that H2 is the limiting reagent here. So here we can say is that the 3 mole of hydrogen will give 2/3 mole of ammonia. So here it will be equal to 2/3 into 0.492. We will get the number of moles here as how much? 0.326 mole. As we have to find out the weight of the ammonia produced, it will be equal to number of moles into its molar mass. The number of moles we get is 0.326 into the molar mass is 17 gram per mole. As a result, here we will get the weight of ammonia produced here as 5.576 gram. And in our next question, we have to find out the VRMS value. And the VRMS value can be found out by the equation of VRMS equal to root of 3 RT by M. So here we can directly calculate the VRMS, because 3 into the R value is universal gas constant, that is 8.314 into the temperature in Kelvin is 308.5. divided by the molar mass of the element is given as 59.9 gram per mole. So as a result, and also have to multiply with 10 raised to minus 3 to convert into meter. As a result, here we will get the VRMS value that will be here equal to how much? 358.4 meter per second. So these are our answers. Hope you have understood the solution. Thank you.